180-degree angle rotated us across 2 corners.
So, all of your ideas were on the right path, at least. We would realistically say the slope is the steepness of the line. Okay, the steepness. So basically, what we're saying here is, if I had something like this compared to something like this, and I had never skied before in my life, would I want to ski down this slope or would I want to ski down this slope? The second one, right? Because if I skied on this slope and I didn't know what I was doing, what's happening? We're doing something bad, right? Running into trees or something, right? We probably haven't broken a lot of whatever.
Yeah.
Is this a good question?
Yes, I believe so.
Okay.
Can ever on a graph there be a ray or no?
Say it one more time.
On a graph, can there be a ray instead of like an independent line, like a point where it stops and goes left and keeps on going, right?
There could be. In geometry.
Oh,
What we're talking about right now, no. We're just talking about linear functions. But there could be, right? Yes? Okay. So, steepness of a line, right? We already talked about this a little bit when we were introducing our lines. Okay, so again, we could have a coordinate plane. Okay. And anything in this general direction, meaning the bottom left to the top right, these are going to be positive slopes. Remember when we showed this to you earlier? And then negatives obviously going the other way. But again, we're talking about the steepness of it. Okay? So this is my negative slopes. When we talk about slope, it's shown by the letter M. Now you're going to ask me why, and I honestly don't know why. It's just M equals, okay? So whenever you talk about slope, you should say M equals, right? And we want to write slopes as fractions. So if a slope is a whole number, can I make a whole number into a fraction?
Yeah, no.
I put it in over 1, right? So I can make any number into a fraction. And so we're going to remember that, all right? So other ways that we can think about this. We're going to have a way to find slope from 2 points. When we talk about this, we're talking about 2 points that are on our coordinate plane. Okay? And there's going to be a formula, and this is something that you really, really need to concentrate on. So, M equals, okay? We're going to have 2 random points. To show this in a generic form, we're going to show, obviously, this is point 1, and this is point 2. Well, there's got to be some way of showing the difference between those 2 points right there. So we're going to put little numbers right here. X, X and Y have the little 1 there, and then these X's have little 2's there. So there's a question before we continue. Any idea, don't say anything out loud, let everybody think what those numbers are called? So if I put them above it, we call them exponents, right? When we worked with them. What do I call these numbers down here? What?
Deponents.
Hey, remember when you weren't supposed to do anything? You need to go to a confession.
What? That wasn't a pun.
What'd you say, kiddo? You think it's a deponent too?
Because it's like the
You
denominator.
have been sitting next to him way too
No,
long.
because it's like it's because of the denominator. It's like
Oh,
the-
rise.
What do I call something,
First and second.
a boat or something that's under the water? Submarine, right? So these are called We really don't know this? Awesome.
No.
You're gonna actually learn something today? These are called subscripts. Okay?
No.
And all they are used to, or used for, is to differentiate between the different ones. Okay, so no D whatevers. Alright? So, M equals, this goes back to finding my slope from these two random points. So instead of having X's and Y's, they're going to actually give you coordinates, numbers, alright? But you're going to come up here and you're going to take the difference of the Y's, so that means we're going to subtract them, and we're going to put that over the difference of the X's. Okay, so the Y's go on the top, the X's go on the bottom, every single time. Now here's the most important part of this whole thing. Okay, besides putting the Y's always on the top, you have to make sure that your subscripts line up. So if you start out by using Y sub 1, you have to have X sub 1 go first too. If you do Y sub 2, you then have to have X sub 2. So up and down, your subscripts have to be on top of each other. So, realistically, I can do the exact same fraction and just flip them around. So I can start out with Y sub 2 minus Y sub 1. But if I do that, I have to do X sub 2 minus X sub 1. Okay, so, hold on, I'll get you. It doesn't matter which way you do it. You're going to get, in a sense, the same answer, but realistically, they won't look the exact same because the signs will be a little different. But this one right here, if you do it this way, and then you switch it to this, maybe the negative sign's on the bottom, compared to the negative sign being on the top. Okay?
Would it be dividing instead of multiplying?
What do you mean, multiply?
Like when you have exponents, you multiply by the same number, but when it's
No.
no.
So there's no number here. There's really no number there. We're going to actually put in an actual number into the spot of X and X here. I'm just differentiating between this X and this X. So there's nothing like an exponent. I understand what you're saying. But does that make sense?
Yeah.
Okay.
Will those points always be given to us?
These points will be given to you,
Okay.
or you'll have to find them on your graph.
Okay.
So basically, they could have just come here and put dots on this, and I can figure out my slope by looking at the dots. And I would figure out where my two ordered pairs are, and then I would stick them into that formula. Okay? So, other ways of thinking about this. You can think about the slope as this. M equals, and use this fraction, or you can think about other ways that you might hear this is the rise over the run. So the slope is how much it rises, how much it runs. Rise always means that I'm going to go up and down. That's why my y's go on the top. And again, if it rises, I'm going to have a plus on the. If it's a positive on top, I'm going to go up. If it's negative on top, I'm going to go down. And then obviously when I run, I'm going to go right or left. And again, I have positive and negative. Now, when I have a negative in my slope, we're going to either put it on the top or on the bottom. One negative, we can put it on the top or the bottom. All right? And we'll talk more about that in just a little bit. Another way that you might see this sometimes is them putting a little triangle here and then say the y's and the x. If you see this, this just means when you see a triangle in front of y's or x's, it means the change of the y's over the change of the x's. So it's just a different way of writing it, just so you can see all those different ways of it possibly being written. Okay? So, the first thing that we're going to do is try to figure out what my slope is from two random points. So, maybe this will help clear up some when you actually see an example. So, point A is at 3, 4, and point B is at 4, 6. So again, they're not going to give you x of 1, x of 2, and so on and so forth. They're just going to give you numbers. You're going to plug them into those things. All right, so you can try to set it up where you're always going to get a positive number on the top. You can always try to set it up where you get the positive number on the bottom, however you want to do it. To me, I've done this so many times that I don't really care if it's positive or negative. I'm just going to do it how they give me the numbers. Meaning, this is my first point, that's how I'm going to write it. I'm going to write this x minus this x, and so on and so forth. But again, if you want to try to always get a positive number on the top, then you'll slow down and look at the numbers and actually set it up that way. Does that make sense what I'm saying there?
Like the bigger one?
The bigger one, right.
But then you would also have to do the second number.
Right, and so then you might not always get a positive on the bottom. So that's totally up to you. If you want to try to do that, again, like I said, it doesn't bother me because I've done it so many times. So it's obviously a little different for you guys. But in this case right here, I would tell myself that this is x of 1 and this is y of 1. I don't have to do this every single time, but maybe at the beginning, maybe I do this just so I'm showing myself what I'm going to do. So then if I write it this way, I'm going to come back and know what spots my numbers are going to go in that formula. So in mine, I'm always going to start out with the y's. So I'm going to do y sub 1 minus y sub 2. This is always a subtraction sign. It does not include the negative if it's on your individual coordinates. So if your individual coordinate is negative, and we'll have examples of this coming up, then you're going to have 2 negatives in that problem. Okay? And we'll show you one of those in a little bit. So because I did 4 minus 6, I have to do what on the bottom? 3 minus 4. Everybody agree? Okay? Then I'm just going to simplify. If I subtract on the top, what do I get? Negative 2 on the bottom? Negative 1. Everybody agree? Okay with that? So then I'm going to simplify. So if I have 2 negatives, what happens? Becomes positive. So my m is actually 2 over 1, or just m equals 2. So, would you consider this a positive or negative slope? Positive, right? That's the sign of that answer. So if I would graph this, one of my lines should look something like this, or it should go in that general direction. Okay? So here's the question. When we talked about the steepness of the line, would you think a whole number is steeper than a fraction?
Yes.
No.
Wait, no. No.
They're just the same number, just turn into a fraction, it'll be the same.
It's going to be the same?
Well, I say, if it's the
A
same.
fraction, like a whole number means.
So if I had this right here, 2 over 1, and I'm comparing that slope to 2/3. Is this, because it's a whole number, steeper or more shallow than 2/3? I want you to think about that as we're going through this, okay? And then we'll come back to that question later on. All right?
But things that you had to, and on the final slope for 2 points, I thought you had to subtract the 2 y's and the 2 x's.
I did. Here's my y's. Y sub 1, y sub 2. I subtracted them. Okay? So let's try another one. So now we put in a negative number. Negative 10, 6. And B is negative 5, 8. Don't worry about the letters in front. Basically, the letters in front are just naming those points. So if you wanted to plot the points and then put a name to that point, that's what you would use right there. So notice now, the only difference between this problem and the first problem is now I have negatives in my actual coordinates, right? And you have to include them. So, which numbers are my y's?
6.
6 and 8.
6 and 8. So, if I write it down the way you said, I'm just going to do 6 minus 8. And if I do 6 minus 8, I have to do my x's in what order?
And negative 10 minus negative 5.
Exactly right. Because we started with this 6, we have to start with that same x. So negative 10 minus negative 5. And if you want to put parentheses in there, that's fine. Exactly right. Okay? Everybody okay with how we set it up? Now, what happens when I have back-to-back negatives? 2 negatives turn into one giant plus sign, right? So on the top, we get what? Negative 2. On the bottom? Negative 5. 2 negatives again, what happens? They cancel out, so my answer is 2/5. So, realistically, this doesn't happen in this problem right here. But let's just say that my answer ends up negative 3/4. Okay? Where's that negative go? Doesn't matter, right? So when you're asked to then kind of use the slope, I would make sure that I show myself where that negative is. Is it on the top? Is it on the bottom? Grace was arguing with herself. Okay? But all 3 of those realistically are the exact same thing, right? One negative makes the whole thing negative. So just make sure that you put it one way or the other. You cannot use this negative both on the top and on the bottom. It's got to be on the top or the bottom. That make sense?
Yep.
What? So then it's going to be a negative slope. And then my line should end up looking something like this. Exactly right. Okay? So, try one all by yourself. C is negative 6, negative 4. And D is negative 8, negative 3. So now, this is a little different again because all of them are negative. But again, just go real slow. Make sure you show your work. And see what you get. How do we do? Everybody get an answer?
Hold on, I'm almost done. Got it.
So again, doesn't matter which way you do it. So again, this would be why I would say to you, it's not really going to matter to me how I write the problem. It's going to be just, I'm going to go and use the first point first, because if they're all negative, I'm going to probably spend more time trying to set it up right than I am anything else. So what are my y's?
4, negative 4, negative 3.
Negative 4 minus negative 3. Right? It's got to have a minus in between. Because I did negative 4 first, I have to do negative 6 first. Right? Now again, watch. Let's do it the other way. Let's just say that somebody did negative 3 first. So I'm going to show you we're going to get the exact same answer. Now they might not look exactly the same at the beginning, but they're going to be the exact same answer. So 2 negatives again turn into one giant plus sign, right? What's negative 4 plus 3? Negative 1 over 2, right? So we get negative 1/2 for my slope. Over here, 2 negatives make a giant plus sign on both the top and the bottom again. What's negative 3 plus 4? 1 over negative 8 plus 6. Negative 2. Look how my negative signs are different, but it's still overall makes the exact same fraction. Okay. Good to go there?
So this would be a negative.
This is a negative slope, either way that I think about it. Okay? Need to do any more of those kind?
That would be the answers. You wouldn't have to do it into ordered pairs.
No. A slope is a fraction. Okay? Should always be a fraction. All right? Everybody good? Yeah. All right, so the next thing we want to talk about are our special lines. So first off, don't say anything out loud, let everybody think for a second. What were my 2 special lines and what variable goes with which special line? Everybody got an answer on their head? Miley, what are my 2 special lines?
Horizontal and vertical.
Perfect. So we have horizontal lines. And we have vertical lines. Okay? Caleb, horizontal has what variable? Y. Y equals, give me a number. 8. Okay? So we got a horizontal line. So obviously my vertical line has x equals, we'll make it a negative. Okay? So, how do I graph this again?
You mark it.
We go what? Where do I go?
Up it.
Up 8, right? Y is always up or down. So I go up 8, and then I would make a horizontal line. This one I'd go where? Left 2 and make a line. Okay? So if this is a horizontal line, it goes this way. If this is a vertical line, it goes this way. So, everybody think, don't say anything out loud. What is the slope of this line? What is the slope of that one? So here's a question. If I was a really bad skier, first time ever, would I like this slope?
Yeah.
You wouldn't go anywhere, right? So basically, I'm standing on my skis, right? Somebody's got to push me because it's flat. So do I have a slope?
No.
So when you say no slope, what's that mean? 0. Okay, but is no slope and 0 slope the same thing? Zero's going to be anything. I know, but how is this and this both 0? No, you can't just make 0 wherever you want. So where's 0? 0 is right here. Okay, so here's a question. If this was me graphing this, right? Where did you tell me to go? Carson said, or somebody said up 8, right? Here's my dot. This would have been at 8. Okay? And if I would have had a dot over here and a dot over here, what would have this dot been if I would have said 1, 2 here and then 1, 2, 3 over here? What would this point be right here?
0, 8.
No, 2, 8.
2, 8.
2, 8. What would this point right over here be?
Negative 3, 8.
Okay? Now, here's the question. You're going to answer your own question right here. Put these 2 points in that formula. And tell me what the slope is. Put those 2 in that formula that we just erased. And tell me what the slope is. Try again.
Zero.
So, every horizontal line has a slope of 0. Every one, it doesn't matter where it's at, up, down, doesn't matter. So if I draw my horizontal line up here, down right there, right on the axis, right there, it doesn't matter. All horizontal lines have a slope of 0. We'd like to ski those, right? If we're really bad. Okay?
But what if you put the 2 before the -3 and then you would add, it would be negative?
Sure. You'd have 2 minus -3. Well, that doesn't matter. Right?
You're still getting the same answer.
Yeah. We're still concentrating on the negative on top.
Oh, 0.
Or I mean the 0 on the top.
Oh.
So even if it's 0, or if it's the second, the x is positive or negative, what is
Yep. Okay? So, what's my answer for vertical then?
1.
So let's do the same thing that we just did over here, right? What's this one?
3.
-2, 3. What's this one? -2, -2. Put it in the formula again.
Yeah. Boom.
So what's my answer?
1.
What?
5.
0,
5.
0,
1.
0,
My answer can't be 0 again because
Oh.
it's totally different, right? So again, do the formula, right? What are my y's? 3 minus -2, right? What are my x's?
1.
What's
I mean 5.
on the top? I get what?
5.
On the bottom, I get what?
0.
What happens if I have 0 on the bottom of a fraction?
no,
Every vertical line has no slope. So no slope and 0 slope are totally different. No slope is empty set vertical line. 0 slope is a horizontal line. Every single time. Okay? Make sense?
Yeah.
Alright. Let's do it this way. Last thing we want to look at is these on a coordinate plane. So if I have my coordinate plane, and let's just say that I have a point right here, and a point right here, and I connect those two dots. Okay? Everybody see that?
Yes.
I'm gonna erase this dot right here. And they give me these two dots right here. Okay?
Yeah.
Can I tell my slope?
Yeah.
How would I tell my slope?
I find those numbers and
Finding what the points are.
Perfect. So, what's this point?
-4, 5.
What's this point?
Here, -4.
And then what would I do?
Beautiful.
I'd use these in the formula, right? Everybody agree with that? I'd bring it back to my formula over here, the rise over the run, and I would figure it out. Okay? Everybody good with that? Here's a different way of thinking about this. Okay? Let's just say that I'm going to be at this point right here. I'm going to make a fraction. I'm going to show you how to find the slope without doing the formula. Okay? So I'm going to start right here. And if I think about a slope, what number is on the top? What variable is on the top? The y. And what direction do the y's go? Up or up or down, right? Y's always go up or down. So if I start right here and I go down to where this point is, I would go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Would you agree with that? Everybody okay?
Yeah.
Okay, so right now I'm right there. And because I went down, it would be a what kind of 9? A negative 9, right? And then from my x to my point, I would go to the right, which is 1, 2, 3, 4, 5, 6. And to the right means that it's a positive. And on the bottom, it's always the x's, which go right or left. And we said it was 6, right? So if I asked you what my slope is by this, you would tell me what? Well, I could use that fraction right there, or I could just reduce it into what?
3, 2. -3 over 2.
Negative 3 halves, right? Now let's talk about our formula. M equals, between these 2 points, what are my y's?
5 and -4.
5 minus -4. All over, what are my x's? If I start with 5, I have to use what?
-4
-4
minus 2.
minus +2. 2 negatives make a giant plus sign. 9 over -6, we get the same exact thing. So you can use the formula, or you can just count. That makes sense? So again, I just counted down 9. That's got me my -9. And then I'm going over 6 to the right, so it was a +6. Okay? I want you to try one of these. Turn your book to page 390. Go ahead, ask your question.
Did you key change? Is that what you did with the -2 minus 2?
That's basically what I'm doing right here. When I turn those 2 negatives into a positive, I'm doing keep change. Yes. Yes, sir?
I found a trick.
Oh.
Yay.
We don't like
It's actually
we don't like Caleb
It's
tricks.
good though.
Hold on.
It didn't prove it.
After we're done, you can bring up the trick. Number 5, I want you to look at number 5. I want you to try to do the counting way for number 5.
What page again?
390.
Oh, I'm 7.
So turn to page 390 and look at number 5. And try to do the counting version instead of doing the formula.
It doesn't matter which one you use.
What do you mean?
Does it matter which point you use?
No, but they already give you 2 points. So I would use those points. But yeah, you can use any, but I would make sure that it crosses exactly at the little black lines. Okay? Don't try to do one like right here. I'm not going to try to use this point right here because I really don't know what that point is.
Oh,
You know what I'm saying there?
I should have known this.
Okay? So, what'd you come up with?
No solution.
-2.
-2 over 3. We're on number 5, Nathan.
Number 5, okay.
Who said that?
Right? Everybody get -2 over 3? So again, anytime that they give me the graph, I'm just gonna count. So if I would've went up, it's a positive. If I go to the left, it's negative. If I go down, it's negative on the top. If I go right, it's positive on the bottom. And then if I would have 2 negatives, I simplify that into a positive. Okay? So number 6, my slope is what?
Zero. No solution.
Zero.
It's horizontal, so it's what?
Zero.
0. All horizontal lines are 0. Mm-hmm.
How would you show your work if you counted like this?
You don't have to show your work if you're going to count.
Okay.
Okay? All right. Questions with any of that? Really important concept, though, for the rest of this chapter especially, but you're going to use this a lot. Okay? You're going to use slope a lot. This is going to be the way to actually graph a lot of your lines. Okay? Questions here?